Okay, I'm back. I have made my raw data table, but we never graph raw data in the IB. We must process our data. So now I'm going to make a table 2, and this is going to be average, I could spell, temperature of water as a function of number of ice cubes. And you can always copy and paste to save yourself some time. Here we go. So this is going to be similar to this table, but it's only going to be the average. So what I'm going to do here is I'm going to highlight this table, copy it, and paste it below. The number of ice cubes, my independent variable, will stay the same. The temperature of the water is going to be what all of this data represents. But now here I'm going to clear all of these contents. So I'm going to right click and say clear contents. And then this is no longer going to be trial 1, it's going to be average. And this is no longer going to be trial 2, it's going to be the standard deviation. This is no longer trial 3. Let's come back to this in a little bit, okay? So for average, I want the average of all 7 trials. So I'm going to put equals, start typing the word average, double click average, and it will, if it does anything like that, I accidentally clicked that D20, you just can delete it. It puts a little parentheses and says, what would you like the average of? So now I need to highlight, I want the average of this trial 1 through trial 7, and then I press enter, and it gives me my average. Nice, right now it gave me the exact amount of decimal places I need to. So I have this average of 40.4 for 0 ice cubes. Now I'd like to see what is the average for 1 ice cube, 2, 3, 4. The way I do that is I hover my mouse until it goes from, see how it's kind of like a little white cross and then it goes over to a little black cross? I hold that down, slide it down all 4, and suddenly, voila, I have the average of all numbers of ice cubes. So this tells me my mean. So if there's 39, 42, 43, 40, the average or the mean was 40.4. My standard deviation tells me how close to the mean were all of my separate trials. So let's go to standard deviation, and we're going to pick of a sample. You would pick of a population if you were counting like species out in the wild. So standard deviation of a sample, and I want the standard deviation again of my 7 trials. I'm going to press enter, and my standard deviation is 2.3. So what does this tell me? This tells me at 0 ice cubes, my average was 40.4, but approximately 68% of my samples will fall between 40.4 plus 2.3, so that would be 42.7, and 40.4 minus 2.3, so that would be 38.1. So 70% of my samples should fall within 1 standard deviation from the mean, and 95% of my samples should fall within 2 standard deviations from the mean. Anything that's outside 2 standard deviations from the mean, I'm going to call an outlier, and I'm going to remove. So in order to check for outliers, I think I'm just going to put standard deviation plus, sorry, not standard deviation, mean plus 2 standard deviations. Okay, again, to get this all to fit in one, I will say wrap text. And then over here, actually over here I want to do minus. I want to show the lowest, sorry. And then I'll copy this and paste it, and I'll put plus. So this will show me what my mean minus 2 standard deviations and what my mean plus 2 standard deviations, that value. And I want to make sure that all of my data is within that range. If any numbers are not within that range, I will call them outliers, I will remove them, and I will recalculate. So in order to do this, I'm going to say equals my mean or my average minus, and then I want to do 2 times the standard deviation. In order to make Excel follow the rules of mathematics, we need to put a parentheses here. So then we say 2 times the standard deviation on parentheses, enter. So my mean, 40.4, minus 2 times this, so this would be 4.6. So 40.4 minus 4.6 is 35.8. You could do that in your head. You could calculate the standard deviation times 2 and then subtract it. I'm just going to do it on Excel though because it makes it a lot easier, because look what I can do now. Now I have all of these means, each individual mean minus 2 times its standard deviation. Now here's the mean plus 2 standard deviations. So that's going to be equals this plus the mean plus 2 times, the times is shift 8 or the little asterisk, the standard deviation, enter. And now I have where all of my data should lie. If you look here, if you look at this data, we were the most precise at 3 ice cubes. Our standard deviation was only 1.7. We were the least precise at 1 ice cube. At 1 ice cube, all of our data, 98% of it should fall, or 95% of it should fall within 34.7 and 44.5. So if I go up here, is this number within between 34.7 and 44.5? Yes, it is. This one, yes. 42.6, yes, 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 yes. And trial 7 barely made the cut. With 34.8, it did make it. So here I would say percent within 2 standard deviations. And I'm going to wrap the text, but this, okay, we'll just do it like that. At 0, between 35 and 45, looks like I have 100%. At 1, I have 100%. I just checked that. Between 33.9 and 41, looks good. Again, trial 7 just barely made the cut with 34, but you have to be within 33.9, so 100. 32 and 39. It looks like everything's above 29 here. Everything's below 38. So you have no outliers. So there are no outliers in this experiment, which is nice for you. And you don't have to remove any of this data and recalculate and do a whole nother table with the average or mean and standard deviation minus your outliers.